Today we're going to talk more about section 10.5, division of radical expressions. So last class we went over both examples 1 and example 2. If you still have questions, make sure you check in during Zoom. And so now we're going to look at example 3 and example 4 today. So now you'll notice that we're dealing with variables. So the first step is the same as what we were doing before. So I'm now going to rewrite this as 2a over root 5b. And so now I'm going to multiply the top and the bottom by root 5b because that's going to get me the square root of 25b squared in my denominator. And then up top, we're going to have the square root of 2 times 5 is 10, a times b is ab. And then in the denominator, the square root of 25 is 5, and the square root of b squared is b. And then up top, we're just left with 10ab. So same process as before, but now we're just adding in variables. So now let's go ahead and look at example 4. Okay, so example 4, very similar to example 2 from last class. Now we're dealing with variables. So it's already been separated. So I have the cubed root of a over the cubed root of, and I'm going to rewrite this 9 as 3 squared, and I'm just going to leave the x. So now I need to multiply the top and bottom by the cubed root of, don't drop your index, that's super important. So 3 squared times 3 gets me 3 to the third power, right? So 3 squared times 3 gets me 3 to the third. And so we're trying to end up with our exponent the same as the index that we're dealing with. And so now I have x times what is going to get me x to the third. So that's going to be x squared. So I'm going to have 3x squared inside as my radicand. So then from here, we're going to look at and multiply just straight across. So now I have the cubed root of 3ax squared, can't do anything with that, over the cubed root of 3 squared times 3 is 3 to the third power, and x times x squared is x to the third power. So then from here, I have the cubed root of 3ax squared over the cubed root of 3 cubed is 3, and the cubed root of x cubed is x. And so this is my answer. Again, looking at example 3 and 4, I don't think I can quite fit both of them. There we go. So we know that we're done with both of these problems the same way we did last class, when you no longer have a radical in the denominator. All right, so now go ahead, go ahead and pause the video and do these 4 examples on your own, and then you can come back and you can check them. Okay, awesome. So for the first one, I ended up with root 4a over root 3b. I'm going to multiply top and bottom by root 3b. And so then I end up with root 12b over 3b because the radicals cancel. But then I can also simplify my square root of 12, right? Because that's root 4 root 3b, because 12 is equal to 4 times 3 over 3b, and the square root of 4 is 2. So I get 2 root 3b over 3b, and nothing cancels. Now if I look at example 4, my index for both of these is 4. So I'm going to multiply both of these by the 4th root of 2 to the third power. And the reason I'm doing the third power of 2 is because 2 times 2 to the third power is 2 to the 4th power. And remember, we're trying to make this exponent here be the same as the index in the problem. So this is now equal to the 4th root of 7 times 8. Remember, 2 to the third is 8 over the 4th root of 2 to the 4th power. So I get the 4th root of 56 over the 4th root of 2 to the 4th power is 2. And that's the answer for that one. Number 5, if I multiply the top and the bottom, first I should probably separate it out. So I get the cubed root of 3x to the 5th over the cubed root of 2y. And then I'm going to multiply the top and bottom by the cubed root of 2 times 2 squared gets me 2 to the 3rd. Y times y squared gets me y to the 3rd. So now up top I have the cubed root of 3 times 2 squared is 4, so 3 times 4 is 12, x to the 5th y squared over the cubed root of 2 to the 3rd y to the 3rd, which is equal to the cubed root of, actually, let's look at this and get some more room here. So I can't take the cubed root of 12, but I can take the cubed root of x to the 5th. I would have one group of 3 x's, so one x can leave, and then I'll have the cubed root of my 12 stays. I had one group of 3 x's with 2 x's left over, so x squared, y squared, all over the cubed root of 2 cubed is 2, and the cubed root of y cubed is y. So that's my answer for this one. And now let's look at this last one. So I'm going to multiply the top and bottom by the cubed root. We're always keeping that same index. All right, 4 is 2 squared, so I'd need another 2 to get it to 2 cubed. X times x squared gets me x cubed, and y to the 5th. Okay, so y to the 5th, this one's a little different than what we've done so far. Y to the 5th just needs to be multiplied by y to get me y to the 6th. And y to the 6th works because 6 is a multiple of 3, and the cubed root of y to the 6th is going to be y squared, because if I were to write it out with my 1, 2, 3, 4, 5, 6 y's, I would have 2 groups of 3. So I'm going to have times y. So now up top, I have my 7x times the cubed root, don't drop the index, of 2x squared y, over the cubed root of 2 squared times 2 is 2 to the 3rd, x times x squared, x to the 3rd, y to the 5th times y, y to the 6th. So now my next step is to simplify my denominator. So I end up with 2xy squared. Up top I have 7x cubed root 2x squared y. And so now I have to double check that anything outside can cancel. So my x's can simplify. 7 and 2 don't have any common factors, so we're good there. So now I end up with 7 cubed root 2x squared y over 2y squared. And so that's how we do all of those problems. All right, thanks for tuning in. Your classwork will look very similar to this practice that we just did, and then you'll also have a homework assignment due next week. Have a good weekend and keep it G-rated.